Okay, in this video we're going to discuss another example that uses a normal table, and the calculation will be just a little bit more involved, but still very doable. So the setup is the same before. We've got a manufactured item that is normally distributed in its weight with mean of 100 pounds and a standard deviation of 4 ounces. And what we're going to compute is the probability that a randomly selected item's weight is within 3 ounces of 100 pounds. Let's see, what color do I want to use here? Let's try that green, that looks nice. Okay, so first I need to define what my random variable is. Capital X is going to be the weight of the randomly selected item, and I'm going to measure that in pounds. And what we want is the probability that X is between, let's see, 99 pounds 13 ounces and 100 pounds and 3 ounces. Okay. Now, whether these inequalities are strict or not does not matter. I could put two less thans here rather than less than or equal to's, and that's because for a continuous distribution, the probability that the random variable is equal to a certain number is 0. So it doesn't matter if you add on those or equal to's or leave them off. So what I'm going to do here is draw my bell curve, and that's something I didn't do in the last example. But I think it's helpful, especially when you have a non-trivial range like this. And my mean is at 100. Okay, so I want to know if I go over here to the right and I go over here to the left, where at the right I'm at 103/16, and at the left I'm at it should be 99. I'm at 99 and 13/16. Remember, this is a PDF, so the total area is going to be 1, and the probability is going to be given by this area, which we compute with a definite integral. Okay. But the most straightforward way to work with the normal distribution is not to directly go to Wolfram Alpha and to compute that integral. We will actually do that once we're done using our normal distribution table, just to show again that it gives the same result. But I want to use the normal distribution table first this time. Now, the normal distribution table deals with z-scores, and that z-score is how many standard deviations the value is away from the mean. And for a positive z-score, it only works with non-negative z-scores. I guess there is 0 on there. It gives you this area, the probability that x is less than or equal to that value, or the probability that the z-score is less than or equal to whatever z-score you have. Okay, so what I want to do is rewrite this probability. This is the probability that x is less than or equal to 103/16 minus the probability that x is less than or equal to 99 and 13/16. Okay, what am I doing here? Well, I'm looking at this area, and this guy right here, the probability that x is less than or equal to 103/16, that's all my shaded area now. Okay, that's from this line over. That probability is represented by that area. And then the probability that x is less than or equal to 99 and 3/16, that's this area right here. So what I do is I take that whole area from this line to the left, but then I subtract this part. And that leaves me with what's inside here. Okay, so what I need to do is find the z-scores for each of these values. And I noticed after doing the last example that I put a subscript on this z-score, whereas I didn't do that in the text. Both notations are very standard. You can use either one. When I put this number down into the right of the z, that's just telling me what I'm finding the z-score of. Sometimes it's convenient, especially in a situation like this, where there's more than one number floating around. So we take the value minus the mean, divided by the standard deviation, which is 4 ounces in pounds. That's 1/4 of a pound. So we'll get 3/16 times 4, that's just 3/4, 0.75. And then for 99 and 13/16, we have 99 and 13/16 minus 100 over 1/4. Okay, on top I'll have negative 3/16, and then I divide by 1/4, and I get negative 0.75. Okay, I'm going to end up running out of room here, so let's see. I'll just write over in this area. So we need to look up our normal distribution table and find 0.75. So if I find 0.75 here, I got 0.7, go over to 0.05, and I get this 0.7734. 0.7734. So if my z is at 0.75, then I get 0.7734 for this area. Now there wasn't a negative z-score. Okay, so this probability is the 0.7734. But what about the other probability? Well, we're going to have to deduce that. Okay. Notice that the normal distribution is symmetric about the mean. So if I want to go out to negative 0.75 on my z-score and find the probability that we're less than or equal to that, that's all that area between the bell curve and the x-axis. And notice that that is the same as the area over here if I were to go out to 0.75. Make it extend a little bit so it looks the same. Okay. And we know that, let's see, let's use green, use a darker green here. We know that this area is 0.7734. That's what we found there. So the probability that z is less than or equal to negative 0.75 is 1 minus that, because it's the same as this area, what's left over, and we know that the total area is 1. Okay, so let me go back. This line here becomes 0.7734, and actually this is approximately. The table only gives approximations, minus, and then I need 1 minus 0.7734. Okay, so that gives us 0.7734 minus 0.2266. And what do we get there? Let me grab my calculator. 0.7734 minus 0.2266. We get 0.5468. So even though the normal distribution table only tells us the area between the x-axis and the normal distribution for positive z values, we can deduce that area for negative z values. And we can do similar kinds of things if we want to deal with a greater than or equal to inequality, and I have an example like that in the text. Okay, last thing I want to do is make sure that this is indeed the same as what we would get if we were to just go straight with a PDF and do an integration. So I'll need to make some space here. Let me clear out this. Okay, in this probability, well, we have a continuous distribution on x. Whoops, I need to switch over to my pencil. So I'm integrating from this value to this value. I'm integrating from 99 and 13/16 to 100 and 3/16. And then I have my PDF. And let's see, the standard deviation is 1/4, and the mean is 100. So I have 1 over the square root of 2 pi. Whoa, that wasn't a pi. Let's make a pi sign here. Okay, times 1/4 is divided by 4, times e to the negative. X minus the mean, mu is 100, so I'll put 100 in there. And then we have divided by 2 times 1/4 squared, so that's 2/16. We're going to integrate that with respect to x. Okay, so let me pull up Wolfram alpha here, and we will integrate that using its approximation for a definite integral. So we're going to integrate 1 divided by the square root of 2 pi divided by 4 times e to the power of negative x minus 100 squared divided by 2 divided by 16. And we're integrating that from x equals 99. Let's see, let me try this. 99 plus 13 over 16 to 100 plus 3 over 16. I haven't tried that before, so I don't know if Wolfram alpha will like that. Yeah, and it was just fine with it. It was just fine with it. So again, we do get to 0.5467. This rounds to 0.5467 if we go to the nearest 10,000th, and if we look back and see what we got, we had 0.5468. So again, there is a slight discrepancy, and that discrepancy comes from how the computer decided to approximate the definite integral here. Okay, as well as the approximation that showed up on the normal distribution table. I mean, this isn't the only time that the area is being approximated. These numbers on the table are also approximations. Okay, so there's an example of a more involved use of the normal distribution table.